Hope everything's going all right. Let's see. Let me share my screen with you guys so you can see what I'm looking at. We'll do it like this. And let me get rid of that there. I know that looks a little weird. Here we go. Okay. So y'all, um, today I'm going to cover 8.3. It talks about the stuff called partial fraction decomposition. I'll explain what that means as we go through stuff. What I'm doing today, y'all, is not on the test, okay? So a couple things, actually, before we get started doing this, I am going to pull up, let's see, I am going to pull up my Blackboard page, y'all. And so I want to say that I sent you guys an announcement the other day regarding the test. So let me actually pull this up first. Okay, so let's see, the review for test 2, guys, is already in Alex. It has 33 questions. So this coming Wednesday, y'all, I'm definitely gonna, that's all we're gonna do on Wednesdays, just review, okay? So let's see. Oh, let me clean my glasses, but it says review has 33 questions. Wednesday, I'm gonna answer questions from the review. So today I'm covering 8.3, and today, y'all, we are gonna have time to answer any questions. So if any of you guys already have any questions, we can do that at the end of class today. So test point 2, y'all, covers chapter 6 and 7, okay? And it has 17 questions on it. So again, what I did, I took questions directly from the review, and all I did is said, when I went through the review, I was looking at it, so I'm gonna pick this one, this one, this one, this one. Same questions. Remember, y'all, when you do the questions, sometimes like it might give you one question, the next time it gives you another one, but they're gonna be from that same group, okay? So y'all, Wednesday, the test will start. I'll have it as open as early as 4 o'clock, and it's going to stay open until Monday night, okay? You can use your calculator, or if you're using one of the calculator apps, that's fine. I did put the formula sheet for test 2 right here. Y'all, I did also include the trig function of special angles in case you're wondering which one that is. It is this one here, okay? And so let me close that up real quick. And then the formula sheet for test 2 is right here. And if you feel like you want to use like the trig identities or anything like that, like the one that we basically used from test 1, you're more than welcome to use that as well, guys, okay? Let's see. And I also set up the test so you get 2 attempts at it, and the second attempt is the quick retake option, okay? So anyway, I wanted to go over that just so you guys are good with that stuff, all right? Okay, so let's go ahead and go over 8.3, which is partial fraction decomposition. Okay, so I know it says previously, well, previously we haven't, but in college algebra at some point, or at some point in our lives, we figured out how to add and subtract fractions, okay? So, and I'll tell you what, we'll actually do this problem, oops. We'll actually do this problem here just so you can kind of see how we work it out. And we'll figure out what we're going to get. So 5 over x plus 6 plus 4 over 3x plus 1. So 5 over x plus 6 plus 4 over 3x plus 1. Okay, so the idea here is if we were going to add these two fractions, we know that when we add fractions, we need a common denominator, right? This is something we've been told ever since we were in elementary school. So our common denominator, or LCD, would be both x plus 6 and 3x plus 1. So, y'all, what I'm going to do here, I'm going to write new fractions with x plus 6 and 3x plus 1 as my denominators. Okay. And up here, we already have the number 5, and over here, we already have the number 4, right? So the idea here, y'all, is we're going to do a little stare and compare. We're going to look at what we have down here, and we're going to compare it to what we had before. So what did we put on the bottom that we did not previously have? So look at what I circled. What did we put on the bottom on the second fraction? What did we put down here that we did not already have over there? Okay, so we do it to the bottom. We got to do the same thing to the top, okay? And then we're going to do the same thing over here. We're going to look at this bottom part, and we're going to look at this bottom part. And we're going to say, what did we put down here that we didn't previously already have? X plus 6, right? Okay, so then we're going to add that up here as well. All right, so now what we're going to do, y'all, we're going to go ahead and start multiplying. So 5 times 3x is a 15x. 5 times 1 is 5, plus 4 times x is a 4x. Oh, come on, pen. And 4 times 6 is 24. All that is over x plus 6, and 3x plus 1. So now, if I combine my terms, 15x and 4x is going to give us a 19x. 5 and 24 is going to give us a 20. Where did we go? 5 and 24 is going to give us a 29, and all of that is all over x plus 6 and 3x plus 1, right? So when we add rational expressions, we find our common denominator, we build up our fractions, right? We say, what did I put on the bottom that I didn't already have before? And if I added it to the bottom, I got to put it on the top, right? And then we combine our like terms and we have our answer, right? Okay, so what partial fraction decomposition talks about, y'all, is we're going to start off with this part, and how do we go backwards and break up the problem, okay? So it's almost like we have the answer, and what we want to do is we want to go back and see if we can figure out the question, okay? So look, I'm going to scroll back over here. And John, do you still need what I have on the screen? Okay, so I'll give you a second to do this. Okay, you're welcome, sir. All right, so what partial fraction decomposition says is, look, we're going to start off with the answer, and how do we go back and write the particular problem, okay? So the way we're going to do this, y'all, is we're going to start off. So again, we know what the answer should be because we have it right up here. Okay, so this is what we should be. This is what we should be coming up with. Okay, so it says we're going to find constants a and b so that 19x plus 29 over x plus 6 and 3x plus 1 is equal to a over x plus 6 and b over 3x plus 1. So we're going to try to find those numbers a and b. Okay, so the directions say we're going to multiply both sides by the common denominator. Okay, so first thing I'm going to do, y'all, I'm going to write this as 19x plus 29 all over x plus 6, 3x plus 1 is equal to a over x plus 6 plus b over 3x plus 1. So our common denominator, y'all, everybody agree that my common denominator here is going to be x plus 6 and 3x plus 1. That's our LCD in terms of this problem. And so we're going to go super, super slow, y'all. Okay. So look, I'm going to go like this, and I'm going to go in slow motion. So the first thing I'm going to do is I'm going to write this as 19x plus 29 times x plus 6 and 3x plus 1. And I'm going to put this 19x plus 29, y'all, in parentheses, okay? Now, remember, what we had on the bottom was we already had this x plus 6 and this 3x plus 1 equals a times, again, x plus 6 and 3x plus 1. We already had an x plus 6 down here, plus b, x plus 6 and 3x plus 1, and we already had a 3x plus 1 here. So all I'm really doing here, y'all, is I'm multiplying that x plus 6 and 3x plus 1 3 times. Notice I haven't done any kind of simplifying yet. I haven't tried to multiply anything. All I did is just kind of put them right next to each other so I know exactly what it is I'm trying to do. Before we go on, are we good on where we got to where we are? We're good so far? Christian, we're good? Yeah? Jennifer, John, am I doing okay? Javier, am I okay? Yeah? Thumbs up? Awesome. Okay. So look, y'all, now we're going to simplify and combine like terms. So what's going to happen with all these fractions, right? Stuff's going to start canceling out. So look, in the first fraction, the x plus 6's and the 3x plus 1's are going to cancel out. We're going to be left with a 19x plus 29, okay? In the second fraction, everybody agree x plus 6's are going to cancel? So I'm going to be left with a times 3x plus 1. And in the second fraction, the 3x plus 1's are going to cancel, and I'm going to be left with b times x plus 6. Okay? All right. I'm almost done, y'all. I'm going to write this as 19x plus 29, and I'm going to start distributing this a. So a times 3x, this is how I'm going to write it, y'all. I'm going to write it as a 3a with an x, and a times 1 is just an a. And then we'll do the same thing here. B times x is just going to give me a b with an x, and b times 6 is going to give me a 6b. Okay, so what we're going to do now, y'all, we're going to do a little stare and compare. I want you to notice something here. We have a 19x, right? So I'm going to write that here, 19x. That's going to be equal to the parts that have the x's. So what I mean by the parts that have the x's are these here. So 3ax plus bx, right? Because those are the parts that have the x's. And then this 29 is going to be equal to the parts that don't have the x's, which is just an a plus 6b. And so what we're going to do now, y'all, we're going to set up a system of linear equations. So the first thing we're going to say is, look, we know that 19 has to be equal to 3a plus b because that's the number in front of the x, right? And these are the numbers in front of the x. So I'm going to say 19 equals 3a plus b, and 29 equals a plus 6b. And what we need to do now, y'all, is we need to solve this system of equations. Okay, so it's probably been a minute, especially if we haven't had college algebra in the last year or so, it's probably been a minute since we talked about, or since you've seen it, I should say, how do you solve a system of linear equations? So a couple of ways you can do it. And maybe you remember, maybe you don't, but in either case, I'm going to show you how to do it. There's one way called, sometimes they call it the addition method or the elimination method, and the second method is called substitution. And you can do it also by graphing, but I don't really want to graph 2 lines today, right, and find where the points that they need. So I'll tell you what, why don't we do this by the addition or the elimination method? So the addition or elimination method, y'all, says, I want to get, say, the same number, say, in front of the a's, but I want them to be opposite signs. So the fact that this one has a 3, I would really like this one here to have a negative 3, okay? So look, if we multiply everything here by a negative 3, I'm going to leave the first equation alone. 19 equals 3a plus b. And I'm going to take my calculator so we can figure out what is 29 times negative 3, negative 87, okay? So negative 87 equals negative 3 times a is a negative 3a, negative 3 times the 6b is a negative 18b. And the idea here, y'all, is that we can take these two equations and we can just add straight down. So again, if I take my calculator and I say, look, I'm going to combine negative 87 with a positive 19. So let me add 19 to negative 87, and I'm coming up with a negative 68. When we add together, those 3 a's are going to cancel out. Remember, y'all, the number in front of this b is a 1b. So plus 1 minus 18 should be something like a negative 17b. And to solve for b, we can divide everything by a negative 17. So we take negative 68 and we divide it by negative 17. I'm coming up with 4. Okay, so we got B is equal to 4. Okay, now that we know B equals 4, y'all, we still need to find the value of A. And the way we can do that is we can come back to either one of these equations, either this equation here or this equation here, and we can plug in the number B equals 4, and we can solve for A. Which equation do we use? It doesn't make any difference. We're going to get the same thing. Okay. So I'll tell you what, I'm going to use this one right here. I'm going to say 29 equals A plus 6 times, we got B equals 4. Okay. So 29 equals A plus 6 times 4 is 24. So when we subtract 24 on both sides, we're going to get 5 for A. Okay. So now that we know that A equals 5 and B equals 4, remember what it was we were doing? I already forgot. I'm going to scroll back up to the very top. This is what we were trying to figure out. What is this part going to look like? And we got A is 5 and we got B is 4. So we're going to say our original problem was 5 over x plus 4 over 3x plus 1, right? And we knew that's what the answer was because we actually did the problem from the very beginning, right? That was actually the first thing we did today. So really what we're doing here is we're going to be kind of given the answer. Like, so we added these two fractions together. What were the fractions that we started off with? Okay, that's kind of the idea in doing these problems. Okay. Okay, I'm sorry. On which part now, Jennifer? Are you good at how I got this part? All right, did I lose you there? Okay, 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 awesome. Okay, so let's go back to this part here. The idea behind the elimination method, Jennifer, says, look, I want to get the same number in front of the A's, but I want them to be opposite signs. So if one of them is a 3A, I want the other one to be a negative 3A. So because the number in front of this A right now is a 1, if we multiply it by negative 3, then this one here is going to become a negative 3A, right? So all we did is we just multiplied everything here by negative 3, and then we started to add those two equations together. So a positive 19 and a negative 87 gave me a negative, and I'll clean this up a little bit so it looks a little bit better. Okay, so when we add 19 and negative 87, we get a negative 68. When we add these two together, they cancel out, right? Because one's a positive 3A and one's a negative 3A. And then a positive 1B and a negative 18B is going to give me a negative 17B, right? So if we divide everything by negative 17, then we come up with B equals 4. Does that make sense? Yeah. So, there's two ways you can go about solving this. One way is the elimination method. The elimination method, this is the idea behind the elimination method. You get to decide which letter do I want to get rid of? Do I want to get rid of my A's or do I want to get rid of my B's? So if you want to get rid of the A's, you want the same number in front of the A, but opposite signs. So if one of them is a 5, you want the other one to be a negative 5. If one of them is a negative 2, you want the other one to be a positive 2. So that when you cancel them, when you add them together, they're going to cancel out. Okay, and I forget where everybody jumps. And you just get to decide which one do you want to cancel. If you want to cancel the B's, so take a look here, y'all. If I look at my problem, look at the number in front of this B. It's a 6, right? So if I wanted to get rid of my B's, we could have multiplied the top equation by what number? By negative 6, right? That's a decision that we have to make for ourselves. Which letter do I want to get rid of, my A or my B? Does it matter? It never does. Go ahead, John. I'm going to show you right now, y'all. So look, y'all, before I go on to the next problem, I'm going to show y'all the other way you can go about solving the system of equations. And if you notice, y'all, we're going to end up with exactly, oh, come on, okay. We're going to get exactly the same thing. let me clean. I probably shouldn't erase it just down on the side, but it's okay. All right. So remember, the first equation we have is 19 equals 3a plus b. And the second equation we have is 29 equals a plus 60. Okay. The other method, y'all, we have is the method of substitution. Okay. So what we're going to do in substitution is we're going to look at the two equations that we have. And we want to solve one of those equations for either the letter A or the letter B. So let me ask you guys a question. If you looked at, say, the first equation, and I wanted to solve that equation either for the letter A or for the letter B, remember what that means. I want to get either the A or the B by itself. Which letter would it be really easy for me to solve for in the top equation? What letter would it be really easy to get by itself? The A or the B? B. Because if I wanted to solve for B, all we would have to do is take this 3a and move it to the other side. Y'all agree it would become a negative 3a? That's what I mean by it was really easy for me to solve for B in that top equation, right? Because all we did is we just moved the 3a over because it was positive, it now became negative, right? Because we crossed equal signs. Okay, so now that we've done that, what we're going to do, y'all, this is a method of substitution. I'm going to take this value of B and I'm going to plug it into the second equation. So look what I'm going to do. I'm going to write 29 equals A plus 6 times 19 minus 3a. Okay. So where this B used to be, we plug that value in. Now we're going to say 29 equals A. Okay, I need my calculator again because I got to figure out what's 6 times 19. 114. 6 times a negative 3 is a negative 18a. Okay. Let me ask you all a question. Can we combine this a and this negative 18a? Okay, so we should end up with, let me do it over here on the side, something like 29 equals 114. A minus 18a, everybody agree, a negative 17a? When we combine those a's together? And then how would I get rid of my 114? How would I move the 114? There you go. Good. We're going to subtract it on both sides. Again, y'all, I'm going to take my calculator right here. I'm going to say, what's 29 minus 114? Negative 85. So I have a negative 85 equals a negative 17a. In order to solve for a, we're going to divide both sides by a minus 17. And you know what we're going to get for a, y'all? Isn't that what we got the first time? When we did our problem and we went through like the elimination method, we got a equals 5. What else do we still need to find? If we know what a is, we still got to find b, right? Okay, so we want to find b. I'm going to come back up here, y'all. I want you to look at something. Look what I have up here in the pink. b equals 19 minus 13a. So I'm going to say b equals 19, or not minus 13a, but minus 3a. Minus 3 times 5. So b equals 19 minus 15. B is equal to 4. Here's my A. Here's my B. The thing that I want to mention here, y'all, whether we use the method of elimination, like we eliminated the A's the first time, or we added those two equations to get rid of the A's, or whether you do the method of substitution, you're going to come up with the same answer. What you get to decide is which way is easier for you. If you like the substitution method, do it. If you like the elimination method, do it, right? It doesn't make any difference because you should be coming up with the same numbers either way.
Is there times where one is not equal to another to a certain question, or is it just about equally hard?
I would say they're both equally easy to do. You know what I mean? I don't necessarily think that one is necessarily better than the other, because again, it's a matter of preference. You know what I mean? It's a matter of which way do you like better. So let me ask you a question. When we looked at the first equation here, and I said, okay, what letter would it be easier for me to solve for, A or B? And right away, John, you said B. Let me ask you a question. If we would have, instead of saying picking the first equation, if we would have picked the second equation, what letter would it have been easier for me to solve for? Would it be easier for me to get the A by itself, or would it be easier for me to get the B by itself? The A by itself, because all you're going to do is move that 6B over, right? See, in the second equation, y'all, if you want to solve for B, you're going to have to move the A over, and then you got to divide everything by 6. And now you got rowdy old fractions all over the place, right? So which one is better? I don't think either of them are better. I think they're both equally the same. Okay. All right, so look, let me keep scrolling here, and let's see. What we're going to do is we're going to figure out how do we start these partial fraction decompositions. Okay, so the first part says make sure the degree of the numerator is less than the degree of the denominator. What the degree refers to, y'all, is the highest power of x. So it says make sure that the degree of the numerator, which is the one on top, is smaller than the one on the bottom. Okay. Number 2, we're going to factor the denominator. So the denominator will factor in what we call linear factors. Linear factors mean that the power of x is just going to be power of 1. Or quadratic factors, okay, which means that we have x squared, that are what we call irreducible over the integers. All that means is that these factors here, y'all, this thing here cannot be factored out. We cannot break that down into 2 linear factors like the way we've talked about factoring before, okay? All right. So then it says there's going to be 1 or more of 4 types. We're going to have linear factors or powers of linear factors, and then we're going to have irreducible quadratic factors and powers of irreducible quadratic factors. Okay, so let's take a look here, and it says set up the form for the partial fraction decomposition given the rational expressions. Okay, so what we're going to do here, y'all, I want you to notice that we have 1, 2, 3 linear factors. Anytime we have linear factors, the way we're going to set this up, y'all, it's going to look like this. Okay, and so my first denominator is x minus 1, my second denominator is x minus 5, and my third denominator is 2x plus 5. Okay, because those are the 3 denominators that we have. And then all we're going to do for the numerators, y'all, A and B and C. Okay. All right. Let's do the same thing for the next one. So for the next one, y'all, I want you to notice that we have 2 denominators, but one of them is a linear factor being squared. So we're actually going to have 3 denominators. One of them is going to be x plus 8, one of them is going to be x plus 1, and the third one will be x plus 1 squared. If we have a linear factor being squared, or to the third, or to the fourth, we kind of have to build it up. We take the linear factor, and then we do the square of it, and if we had a third, we do the third of it, and we had a fourth, we do the fourth of it, okay? And then just like we said before, y'all, anytime we have linear factors, my numerators are just coefficients. They're just some values, A, B, and C, okay? Again, all I'm doing here, y'all, I'm setting them up. I'm not actually going to solve them yet, okay? All right. Now I want you to look at the third one. Again, we have a repeated linear factor. We have 2x plus 3 raised to the 4th. So since we have 2x plus 3 raised to the 4th, that tells me, y'all, we're going to have 4 fractions. One of them is going to be 2x plus 3 as the denominator. The other one will be 2x plus 3 squared. And again, we have to kind of build this up. 2x plus 3 to the 3rd, and then 2x plus 3 to the 4th. And then again, I'm just going to take my coefficients, whatever they're going to be, A, B, C, and D. All right. So guys, before I get to number 4, I want you to notice something about problems 1, 2, and 3. If you look at the denominators were already factored for us in problems 1, 2, and 3, meaning the denominators, the bottom parts were already broken up into factors. When I look at problem number 4, the bottom part here is not factored, okay? So we need to do a little bit of factoring. So the first thing I'm gonna do, y'all, I'm gonna do a little zoom in right here, okay? And what I wanna do is I wanna see if we can factor this denominator. Okay, so I'm gonna write out the denominator, x to the third minus 3x squared plus 25x minus 75. Now, y'all, if any of you had taken Math 100, and I'm sure you guys probably didn't, and if you did, it was like years and years and years ago, but this is one of the things we do like in remedial math, is we figure out how to factor stuff, okay? And so if you don't remember this, this is fine, but I'm gonna show you. Anytime you have 4 terms, y'all, and if you notice we have 4 terms, we're gonna try to do the method of grouping. What grouping says is look at the first 2 pieces. Don't worry about anything else. Just look at those 2 pieces. What can we factor out? What's the highest power of x that we could take from both of them? So we got an x to the 3 and an x squared. What's the most x's we could take from both those 2 pieces? X squared. Good. And if we did that, what would we be left with inside those parentheses? There you go. Okay. Y'all, we're going to do the same thing we did a little while ago. Now we're going to look at the second 2 pieces. All I'm doing is I'm looking at 25x minus 75. What is the largest number that I could factor from both 25 and 75? What's the largest number that goes into both of them? What number can you divide both into 25 and into 75? Anybody know? 25, very good. So look, y'all, if we take out a 25, what's the only thing I'm going to be left with in the first part now? Just an x. How many times does 25 go into 75? Okay. Now, we know if we did this right, if this piece here and this piece here match up, and notice, easy breezy cover roll, they do, x minus 3. My other factor, y'all, is going to be this one here, x squared plus 25. Now, x squared plus 25, I cannot factor it, okay? Earlier this semester, we did talk about factoring the difference of squares, where we have like x squared minus 25 or y squared minus 49, but if it's a plus, I just can't do it, okay? So what we're gonna do now, y'all, I'm gonna zoom out, okay? And we're gonna write this as 5x squared minus 5x plus 72 over, we have an x minus 3, and we have an x squared plus 25. Now we can get started. So the first thing we really had to do is we had to factor that bottom part. Okay. So, y'all, we're going to have 2 parts to this. One of them, the denominator is going to be x minus 3. The other one, the denominator is going to be an x squared plus 25. Anytime we're dealing with what we call linear factors, y'all, where the power of x is just 1, my number I'm going to have on top is going to be numbers like A, B, C, stuff like that. But I want you to notice that this one here is not just an x. It's an x squared plus 25 that I cannot factor out. When I have an x squared, my factor on the top, or my component to the top, y'all, is going to be a linear component. It's going to be in the form bx plus c, ax plus b, whatever it happens to be. The reason I'm not using a is because we already used a for the first part. Okay. So anytime I have x squareds in my denominators, my numerator should have a power of x. Okay. And again, all I'm doing here, y'all, is just kind of doing the setup. Bx plus some other, yeah, it has to, if my denominator is a quadratic, then my numerator is going to be a linear vector. Yeah. Okay. All right. And we have one more. So we have x to the fourth plus x to the third minus 3x squared plus 6x minus 36 all over x and then x squared plus 6 being squared. The difference in this problem, y'all, and the one we did before, the denominator here is already factored for me. Okay, so first thing I want you to notice, we have a factor of x. There's my first denominator. We have a factor of x squared plus 6. There's my second denominator. But because the whole thing is being squared, remember, that means that there's two of them. So I'm going to have one more of x squared plus 6 all being squared. Okay. Just like we did before, if we have factors that are powers, then we have to sort of build it up. Okay. All right, first thing I notice, this one here is a linear factor. So my top part is just going to be some value a. This part here, y'all, is a quadratic factor. So this is going to be bx plus c. The numerator component has to be a linear component since the denominator is quadratic. Same thing over here, because this is also quadratic, this is going to be now dx plus c, right? And all I'm doing is I'm just, picking random letters, but I'm trying to go in order, A, B, C, D, E, right? And again, this is just the setup. All right, so now let me go ahead and scroll a little bit further. Okay, so we want to see if we can find the partial fraction decomposition. Okay, so we're going to decompose this thing here, y'all. First thing I want you to notice is if I look at my denominator, it is not currently factored. So we're going to do that. So the first thing I'm going to do, I'm going to write x to the third plus 2x squared minus x minus 2. Okay. Now, y'all, I can do this anytime I have four terms, we can always factor by grouping. So this is what we did a little while ago. Anybody know what can we factor out of x to the third plus 2x squared? What can we take out of there? Anybody know? X squared, good. If we take out an x squared, what are we left with inside? There you go. Perfect. Now, I'm going to circle these two terms, and I'm going to ask you a question. Is there anything we can take out of a negative x minus 2? Any number that goes into both of them? Negative 1. So if you notice, guys, they're both negative. We can take out a minus 1, and we're left with x plus 2. And now notice, like I told y'all before, if those pieces match up, y'all, excuse me, we're doing this right. So this is going to be an x plus 2, and then my other factor here, y'all, is going to be an x squared minus 1. Now, I'm not quite done yet, okay? X squared minus 1, y'all, we can factor that, okay? So I'm going to show you how I'm going to factor x squared minus 1. There you got it, my friend. X plus 1 and x minus 1. Y'all, we can factor the squares like that when it's a difference, meaning there's a minus in the middle. If there's a minus in the middle, x plus whatever the square root of that number is, in this case, the square root of 1 is 1, and then x plus 1, x minus 1, x plus 1. If this would have been x squared minus 25, x plus 5, x minus 5. If it would have been x squared minus 49, x plus 7, x minus 7, okay? So you can do it as long as the term in the middle is a minus. If the term in the middle is a plus, it's kind of like when you were a kid and you played Simon Says. Simon Says, raise your hand. Simon Says, lift your right foot. Touch your head. Oh, Simon didn't say, right? So you're out. You can't do it if it's plus. If it's minus, it's going to work.
So, how do you go from negative 1 times x to x squared minus 1?
Okay, so as long as this piece here and this piece here match, John, that's going to go right here. This guy and this guy become one factor right here. Better? Good, good. All right. Let me ask you a question, y'all. How many of us, how long has it been since y'all have done some factoring? You remember a while? Long time? It's been a long time. Will your calculator do it? Good. Your calculator will do it, guys. But yeah, it's been long. That's why I said, like, in all honesty, guys, if y'all had been, like, if we were in Math 100, like, say, last semester, this part here would probably be real easy, but then y'all wouldn't have been able to do all the trig stuff, right? Because in Math 100, we do a ton of factoring. Anyway, so let's come back to the original problem. Look, y'all, so I'm going to write like this. Look, we have 4x squared plus 3x plus 5 over, now we have x plus 2, x plus 1, x minus 1, and that's going to be equal to 3 parts. Okay. 1, 2, 3. One of them over x plus 2, one of them over x plus 1, one of them over x minus 1, a plus b plus c. Okay. Y'all, in the problems that we just did a little while ago, all we were doing was setting those up. This one here, we actually want to solve. We want to find out what's my number A, what's my number B, what's my number C, okay? So this is what we're going to do. We're going to go super slow. Put brackets around all this business here. And we're going to multiply everything by our common denominator, which is x plus 2, x plus 1, x minus 1. And we're going to go 1, 2, 3, and then one more over here, 4. Okay. So let me ask you all a question. What do you think is going to happen when we multiply this one here times this one here? What do you think is going to cancel out? Will all the denominator cancel? What do you think? So look, y'all, I'm going to multiply this guy here times this guy here. Let me ask you a question. Will the x plus 2 cancel? What do you think? Yeah. Okay. Will the x plus 1 cancel? Yes. Will the x minus 1 cancel? Is there an x minus 1 over here? Okay, it's going to cancel. So all we're going to be left with is 4x squared plus 3x plus 5. Now, I'm not trying to get you down yourself. I'm trying to get you guys to look at it and say, hey, you know what? Because the numerator I have here is the exact same as the denominator that I have here. Every one of those pieces will cancel out. I'll just be left with what I originally had in my numerator, right? Okay, so now let's take a look here. Look at this one here. When we multiply this guy by this piece here, which ones are going to cancel? When we take this guy here and we multiply it by this part, what part's going to cancel? Okay, so do you agree with me? We're still going to have the letter A, and we're also still going to have an x plus 1 and an x minus 1. Okay, let's do the same thing for the next one, y'all. Look, we're going to do it. We're going to go slow. What's going to cancel with the b over x plus 1? Okay, so we're going to be left with the letter b and an x plus 2 and an x minus 1. Okay, and then one more. What's going to cancel with this one here? The x minus 1, so we're going to be left with a c. Very good. X plus 2 and x plus 1. Okay. All right. So guys, what we're going to do now is we're going to do a little bit of the FOIL method, okay? I'm not going to worry so much about this piece right here, y'all, because nothing is really happening with it, so I'm not going to worry about that part too much. What I'm going to do is I'm going to have my A here, and we're just going to go real slow. Remember the FOIL method? The first term. What's x times x? X squared. Good. X times a negative 1 is a negative 1 with an x. 1 times x is a positive 1x. And 1 times negative 1 is a negative 1. Again, all I'm doing is I'm just pulling out those parts that are in front of my A's. I'm going to do the same thing, y'all, with the X's for the B's. Okay. So look, I'm going to go real slow again. X times X is X squared. X times -1 is a -1X. 2 times X is a positive 2X. And 2 times -1, -2. Okay. Y'all are doing great. I'm going to do the same thing with my C. Okay. So X times X is an X squared. X times 1 is a 1X. 2 times X is a 2X. And 2 times 1 is a 2. Okay. No, you don't have to write 1X. I'm writing it there just so that everybody can see what I'm writing. Okay, so look, y'all, now we're going to worry about some combining like terms. In the middle, those two terms in the middle on all three of these parts should combine. So in the first one, -1X and plus 1X cancel out. This is an X squared minus 1. Okay. Now we got a B. Let's see, an X squared. A minus 1X and a plus 2X is a plus X minus 2. And then for my C, we have an X squared. A 1X and a 2X is a 3X plus 2. All right. We're almost there. I'm going to start distributing my A's, my B's, and my C's, y'all. Okay, so let's take a look here. This is going to give me an AX squared minus A when I distribute that A to both parts. And a BX squared plus BX minus 2B. And then plus CX squared plus 3CX plus 2C. So far, so good? Okay. So look, y'all, we're going to start doing some combining like terms. I'm going to take all my X squared pieces and put those together. So I'm going to say, look, AX squared plus BX squared plus CX squared. That's going to be equal to the X squared term that we had on my answer. Remember over here when everything canceled out, we still had that 4X squared? So that's going to be equal to 4X squared. Okay. Now, I'm going to start combining my X terms. So my X terms looks like a BX and a 3CX. So a BX and a 3CX. And that's going to be equal to 3X. And then I'm going to take my constant terms. What I mean by my constant terms, the ones that don't have any X's. And that should be equal to 5. Because that's the number that I got right there. So 5 equals, let's see, I have a negative A, a minus 2B, and a plus 2C. Okay. All right. So y'all, what I'm going to do now is this over here on the side, I'm going to write out my system. So this means that 4 equals A plus B plus C. 3 equals B plus 3C. And 5 equals negative A minus 2B plus 2C. Okay, so what we need to do here, y'all, we need to see if we can solve this system of equations. So remember what we said we could do. We can solve one equation for another. We can start eliminating some of the variables. Just by looking at this equation, y'all, would we be able to eliminate A's or B's just by adding any equations together? So let me ask you a question. What's the number in front of the A in the first equation? What's the number in front of the a in the second equation?
Zero,
And I'm sorry, in the third equation. I'm sorry, that was my mistake. In the third equation.
negative one,
So if we took the first equation and the third equation and added them together, would you guys agree that the a's would cancel out? Yeah? Okay, so let's do that. Let's take the first equation. So I'm going to write 4 equals a plus b plus c. I'm going to take 5 equals negative a minus 2b plus 2c. I'm going to add these together. That's going to leave me with a 9. Those are going to cancel out. A b and a negative 2b should be a negative b. And a c and a 2c should give me a 3c. Okay? So look, y'all, we came up with a new equation by adding the first and the third together. Now, I'm going to ask you a question. If I take that equation that we just found and I look at my second equation, what letter do you think we could get rid of now? Everybody agree B? Can we get rid of the B's now? Because look at the number in front of this B. It's a negative 1. Look at the number in front of that B. Isn't that a positive 1? So if I wrote 3 equals B plus 3C, and we added straight down, that would give me 12. The B's would cancel. 3 and 3 would give me 6, 6C. So what do I need to do to solve for the letter C? Divide by 6. And y'all agree that we're going to come up with C equals 2? Okay. Now that we know that C equals 2, could we find the value of B? Could we use, say, this equation right here? Okay, so we might say, look, 3 equals B plus 3 times 2. So that's going to give me 3 equals B plus 6. So if I minus 6 on both sides, would you all agree that B would be equal to negative 3? All right, so let me ask you a question. If we already found the value for B and we already found the value of C, could we find the value of A? Could we say, come back to say the top equation? And we could say something like 4 equals A minus 3, because B is a negative 3, plus 2, because C is a positive 2, and 4 equals negative 3 plus 2 is a minus 1. So if we add 1 to both sides, wouldn't we come up with A equals 5? Okay, so now that we got that, this is what I'm going to do, y'all. I'm going to come back to my original problem. And I'm going to zoom in up here. Remember how we wrote it up here at the very beginning? We wrote it right here. I'm just going to write that over here on the side. So for A, we came up with 5. So we had 5 over x plus 2 plus, for B, didn't we have a negative 3? So negative 3 over, what was it, x plus 1? And then C was a positive 2 over x minus 1. And this is what we call partial fraction decomposition. Okay. So guys, I'm going to give you a heads up. I know some of you are going to take Calculus 1 next semester, some of you are not. Whenever you guys take Calculus 2, that's when you're going to see this. It's not in Cal 1, but it's going to be in Cal 2, okay? I'm sorry?
How would we do it organize this
So in Calculus 2, when you're going to see this, in Calculus, there's a couple of like main ideas that we talk about. And one of them are derivatives and one of them are anti-derivatives. And I don't know if any of you guys took calculus in high school, something derivatives, sometimes called intervals. when you start integrating more complex algebraic expressions, sometimes you end up with these kind of partial fraction problems. And that's how you have to do it. But that's not like a real basic integration problem. We do a little bit of basic integration in Cal 1. The more complex integration you see at the calculus 2. So you'll see something called an integral or an antiderivative, and you'll see that in calculus 2. But how do you take the antiderivative of something more complex? You do break it up into partial fractions. Okay. All right. I'm sorry? It's a lot of writing. There's no doubt about it. It is quite a bit of writing. So y'all, for this next problem here, we're actually going to skip this one here. I did not. So one thing I want you to notice about this problem, and I'm going to kind of zoom back up to the top just so you can kind of see what I'm referring to, and then I'll tell you why we're going to skip it. Where it says how to begin partial fractional decomposition, it says make sure the degree of the numerator, that's the highest power of x on the top, is smaller than that of the bottom. This one here, what's the highest power of x on the top? Third. And the one at the bottom is second. Okay. So I didn't put any of those problems in your homework because the homework problems were much more complex than like the one that we would do here. So I didn't add that into your homework, okay? So instead of doing number 7, we are going to go straight on to number 8, okay? All right, so it says find the partial fraction decomposition. Okay, so first thing, y'all, is I look at my denominator and it appears to be factored. The one thing I need to make sure is, and they are going to be like this, y'all, but this is what we call irreducible quadratic factors. So I want to explain why this here is what we call an irreducible quadratic factor. So again, I know it's been a while since you guys have seen factoring, but I'm going to show you how do we know I can't factor this thing out. Anytime, y'all, would y'all agree with me that the number in front of this x squared is a 1? Okay, so anytime the number in front of the x squared is a 1, these are what I call the easy breezy cover girl factoring problems. What you would do is you would say, look, when you multiply 1 times 3, everybody agrees you're going to get the number 3? We're looking for two numbers that multiply to 3, but they would need to add to this number here. The only thing is, the only numbers that I know multiply to 3 are 1 and 3. And if you add 1 and 3, what number do you get? Okay, and we don't want 4, we want to get 2. The other numbers that I would know, guys, that would multiply to 3 would be -1 and -3, and in that case, that would give you a -4. And that's not what we have. That's why we say this thing here is irreducible. I cannot factor it. Okay, it just can't be factored anymore. Okay, so that's just kind of like a little, quick lesson on how do you factor when the number in front of your x squared is a 1. Okay, so what we're going to do, y'all, we're going to rewrite this problem so it looks like this. -8x squared minus 10x minus 6 over x plus 3 and x squared plus 2x plus 3 is equal to. Now we're going to have two denominators, y'all. One of them is going to be x plus 3, and the other one is going to be x squared plus 2x plus 3. Okay. Since this is a linear factor, the numerator component is just going to be an 8. Since my denominator here is a quadratic factor, my numerator component is going to be a linear component. It's going to be in the form bx plus c. Okay. So what we're going to do now, y'all, is we're going to multiply everything by the least common denominator. Remember, the least common denominator, y'all, is just going to be the x plus 3 and the x squared plus 2x plus 3. Okay. All right. Again, I'm going to think about this being over 1, and we're going to go 1, 2, and 3. So again, y'all, I'm going to ask you a quick question. I'm going to take this piece here, and I'm going to multiply it by this piece over here. What parts on the denominator on the second part are going to cancel out? All of it. Excellent. Good. So do you agree with me we're going to have a -8x squared and a -10x and a -6? Okay, now on the part that has the a over the x plus 3, when we multiply that by our common denominator, what part's going to cancel? Very good. So we're going to be left with an a times x squared plus 2x plus 3. Okay. And then on the part that has the x squared plus 2x plus 3, what part is going to cancel? The x squared plus 2x plus 3, right? That part's going to cancel with this one over here. So we're going to have, look, y'all, I'm going to write this bx plus c, and I'm still multiplying that by an x plus 3. Okay, so I'm going to go real slow here, y'all. We're going to multiply the a times each of these three parts. So we should have an ax squared plus a 2ax plus a 3a. Okay. Now, we're going to FOIL out the second piece. So we're going to go super slow. Remember, FOIL stands for the first terms. Bx times another x, bx squared. Good. What about bx times 3? There you go, 3bx. Good. C times x is just a, good, and c times 3 is just a 3c, right? Okay. All right, y'all. Now we can start setting up our system of equations. So look, we know that this negative 8x squared is going to be equal to the parts that have the x squareds, which in our case is just an ax squared plus bx squared. And then we know that this part here that has a negative 10x is going to be equal to the parts that just have an x, like a 2ax and a 3bx and a cx. Okay. And then we know that this part here that has the negative 6 is going to be the parts that just don't have any x's or anything. So like the 3a and what, 3c? Okay. All right, so let's see what we can do here, y'all. Let me see. Okay, I'm going to start writing out my equations now. So if I look at this part here, this means that negative 8 is equal to a plus b. This says negative 10 equals 2a plus 3b plus c. And this says, guys, before I do anything else, do you think we could divide everything here by, say, 3 in that bottom equation, just to make our numbers a little bit smaller? And if we divided everything by 3 in that bottom equation, y'all agree with me I'd come up with a negative 2 equals a plus c, something like this, if you just divided everything by 3. And this way, my numbers aren't as big as I had before. Does that make sense? Okay. Let me ask you a question. Let's see here. Oh, my goodness. So if I look at the top equation, it only involves the letters a and b. And if I look at the bottom equation, it only involves the letters a and c. And the middle one involves all three of them, right? Yeah, well, could we do this? Could we, if I looked at, say, these two equations, could we cancel out, say, the c's and come up with an equation that only had a and b? Could I get rid of my c's in that by combining these two here? Like, say we multiplied, yeah, say we multiplied this thing here by negative 1, right? Would you agree with me that we'd come up with a positive 2 is equal to a negative a minus c? And then if we took the second equation, negative 10 equals 2a plus 3b plus c, and we added that to it. So look what we're doing. We're multiplying the bottom equation by negative 1, and then we're going to take the second equation, and we're going to add those two equations together. Wouldn't we come up with something like, say, a negative 8? A negative a and a 2a would just give me a positive a? and then a plus 3b, and my c's would cancel? Is that making sense, how I'm adding those together? What do you think? So look, y'all, all we did is we took this equation here. We took this equation here and we multiplied it by -1, right? And that's how we came up with this part. And then this second equation, I just copied it down again. And I said, look, if I add those two equations together, a -a and a 2a gives me a positive a. I'm going to bring down my 3b, my c's are going to cancel. Now, the reason why I wanted it, yes. And we know that -a equal, or -8 equals a plus b. So now, is there a way that we can sort of get rid of either a or b by using this equation? What could we do to say that equation? Could we multiply that equation, say, by -1? Okay, so let's go slowly, y'all. Look, what's -1 times -8? Positive 8, right? -1 times a, -a. -1 times b, -b. Okay. Now look, we're going to add these two equations together. -8 and 8, 0. What's going to happen to my a's? Anybody know? Cancel out, okay. 3b minus b is a 2b. So if we divide both sides by 2, what did we just find out b is equal to? B is equal to 0. Well, hey, look, if we know b is equal to 0, can we use that in the top equation to solve for a? Okay, so if b equals 0, then -8 equals a plus 0, which tells me that -8 is equal to a. So look, we know that a is equal to -8. We know that b is equal to 0. Can we find the value of c? Can we use the second equation? Can we use the third equation? Can we use either one? What do you think? Can I use either one of those two? Third equation. Okay, so look, if we use the third equation, I'm going to write -2 is equal to a, which we got -8 plus c. So I'm going to add 8 to both sides. Okay. So -8 and 2 is 6. So 6 is equal to c. Okay. All right. So we found our values for a, b, and c. I want to show y'all something. Look over here. Remember how we had a over x plus 3? So we're going to say this is going to be equal to -8 over x plus 3 plus, what did we get for the value of b, y'all? 0. So that piece is just going to not even be there, right? So c is the number 6 all over x squared plus 2x plus 3. And we found our values for a, b, and c. What do you think? Are these problems coming out okay? Are they just long? They're long? Okay, let me ask you a question. What do you think so far, what would you say is the hardest part? Like, do you think the hardest part is when we get to this part right here and we say we have the system and we're trying to figure out, okay, I have a system, one of them has a plus b equals -8, the other one is -10 equals 2a plus b, or 3b plus c, and the other one is -2 equals a plus c. How do I go from there to finding my a, b, and c? Do you think that's the hardest part? Like, how do I rationalize, how do I get to, from here, what I have right here, y'all, how do I get to, from this part to deciding what should I cancel out? Should I cancel my a? Should I cancel my b? Should I cancel my c's? What do you think the hardest part is? Is keeping track of what? Oh, just keeping track of stuff in general? Okay.
I'm gonna mess up one number somewhere and throw in the whole thing.
So yes, so guys, that's the other thing. Um, when you're doing this part, and I'm gonna kind of back up a little bit here. When we got to this step, and we have to like distribute that a and multiply that bx plus c times x plus 3. Anything like that, if your problem is coming out wrong, usually what I always tell my students to do is sometimes it's harder to like look for the mistake where you made the mistake, and sometimes it's just easier to say, you know what, let me just redo the problem, right? Because where am I gonna? I'm like trying to scroll through. Where is my error? And look at all the mess that I got, right? I got a ton of mess up here. Where's my mistake? I don't know. You know what? Let me just start again. Let me see if I can do this again. Okay.
On the inside, what's the
Over here.
is it negative eight x squared minus 10x minus 6 equals that? Or
Yes. Yes. This thing here is equal to that part there.
is it with the denominator or without the denominator?
Yeah, with the denominator. So this piece here, John, is equal to that piece right there. All right, so I think we got one more here, y'all. So let's see if we can't figure this one out. Okay, so it says, find the partial fraction decomposition. First thing I want you to notice, y'all, is that on the denominator, we have a quadratic, and it's not just a quadratic expression, it's a quadratic expression being squared. So we're gonna have to sort of build this up, right? So look, this is what I'm gonna put. I'm gonna put it like this: 5x squared plus 2x plus 31 all over x squared plus 6 all being squared. We're going to have two denominators. One of them is going to be x squared plus 6. The other one is going to be x squared plus 6 being squared. Okay. Now, since my denominators are quadratic expressions, then my numerators, y'all, the stuff on the top is going to have to be in a linear component, meaning this is going to have to be like an ax plus b, and this is going to have to be in the form cx plus b. Okay. All right. So once I write that out, my next part is to take the common denominator, which in our case is x squared plus 6 being squared, and multiply it 3 times. We're going to go 1, we're going to go 2, and we're going to go 3. All right. So just like we did before, y'all, I'm going to circle this part right here, and I'm going to circle this piece over here. Y'all agree that the x squared plus 6 all being squared is going to cancel out? Because this piece right here is the exact same as that piece right there, so that's just going to go away. And I'll be left with a 5x squared plus 2x plus 31. Okay. All right. Now, we're going to go slow here. We're going to take this part and we're going to multiply it by this. Guys, do y'all remember what x squared plus 6 squared means? Doesn't that really mean, I'm going to just kind of clean this up a little bit. Doesn't that mean that there really are two of them, right? So won't this guy here say cancel with one of them, but there's still going to be one left? So I'm going to have an ax plus b times that x squared plus 6. Okay. And then when we multiply this part here with both of those, they're going to cancel again. So I'm just going to have a cx plus b. John, am I good? So because this part is being squared, doesn't it cancel with both of them?
Yeah.
Okay. Okay. Okay, y'all. So look, we're going to start going real slow. We're going to take ax times x squared. That should give me, everybody agree, ax to the third? And then ax times 6 is going to give me a 6ax. And then b times x squared is going to give me a bx squared. And then b times 6 is going to give me a 6b. All right, so we're almost there, y'all. We're going to start setting pieces up. So first thing I want you to notice here, I'm going to start looking at my x squared. So we have a 5x squared, and that's going to be equal to all the pieces that I have x squareds on. Well, the only piece that has an x squared is bx squared, right? Okay. Okay, and then look, I'm going to look at the next part. It has a 2x. So 2x. I'm going to look at the parts that all have an x. Looks like a 6a. Oops. 6ax and a cx. And then I have a 31, and that's equal to the parts that just have no x's. So like a 6b and a d. Okay? And we're almost, there's one more piece, y'all. I want you to notice something up here. Do you see how this part has an ax to the third? Did we have any x to the thirds in our part over here? That means that the number in front of the x to the third, y'all, is 0, because there's no x to the thirds. That means that a is equal to 0. So we're going to go real slow. So look, this means, the first part means that a is equal to 0. The second part means that 5 is equal to b. The third part means that 2 equals 6 times a, which we already know was 0, plus c. And the fourth part means that 31 is equal to 6b plus d. Okay, do you think we can find the values for a, b, c, and d? Well, we already know the value of a, and we already know the value of b, and don't we actually already know the value of c? Okay, so we know that a is 0. We know that b is 5. Let me use black marker here. So I know a is 0. We know b is 5. We just found out that c was 2. And I bet you we can find the value of d, right? So look, if 31 is equal to 6 times 5 plus d, 31, 6 times 5 is 30. So d is equal to 1, right? Oops. Okay, so let me zoom out a little bit, just so we can see that. So d is equal to 1, okay? All right, so now we're gonna go ahead and write out our expression. So remember, we're writing this part right here, y'all. So a is 0, so I'm not gonna worry about it. B is 5, so we have a 5 over x squared plus 6 plus c, which was a 2 with an x, plus d, which was a 1, all over x squared plus 6 being squared. So remember what I'm doing here, John? I'm coming back and I'm looking at this ax business, and I'm just filling in my numbers for a, b, and c. So since A was 0, I didn't even worry about it, right? And then it had plus B, and B we came up with the number 5. So 5 over x squared plus 6 plus C, which was the number 2, and then right next to it was an x, so I had to put my x plus B, which was a 1, all over x squared plus 6 squared. That system was probably the easiest system to solve, right? For the A, B, C, and D. A was already given to us. B we found really easy, greasy cover girl. It was really easy to find C, and the hardest one was to find was D, and that was not too tough either. Right? Okay, so let me. It may. So look, y'all, let me stop recording. Let's see.